Hello students, I would like to explain the question bank of mechanical properties of solids today. First question is, what is the pressure required to reduce the given volume of water by 4%? Fractional change in volume is delta V by V equal to 4%, that is 4 by 100. Wait a minute, 4 by 100. Okay, and also see here he has given bulk modulus. Bulk modulus B is equal to 2.2 into 10 to the power of 9 pascals. So he has asked to find out what pressure required. We know that bulk modulus equal to pressure required by delta V by V. So here we need to find out delta P. Delta P is equal to B into delta V by V. By solving this, you will get the answer for this question. Okay, next one. Second question, the actual length of a wire is 2 meters and diameter is 4 millimeters. Length is 2 meters. Diameter D is equal to 4 millimeters. If a 20 kg object is hung with the wire, if 20 kg object is hung with the wire like this, so here force acting is nothing but M into G. So force F equal to 20 into G is 9.81. So you will get it as 20 into 9. It is approximately 192 newtons. Right. And the wire is extended by, the extension of the wire is also given, delta L equal to 0.75 mm. Converted into meters. What is the Young's modulus? We know the Young's modulus equal to stress divided by strain. Longitudinal stress divided by longitudinal strain. Longitudinal stress is nothing but restoring force per unit area divided by delta L by L. So you will get F into L by A delta L. He has given force M into G. You got the force value. Length is 2 meters. Area can be found out with the help of pi r square or pi d square by 4. Area is pi d square by 4 because r equal to d by 2. R square is nothing but d square by 4. And here delta L value is also given. So you can find out the y value. It will be turned out as 4.16 into 10 to the power of 10 pascals. The answer for first question is 8.8 into 10 to the power of 7 pascals. This is the answer for first question. Now, which of the following statements is correct? Strain is always proportional to stress. Strain is proportional to stress within elastic limit. Hooke's law says this. So answer is B. And next fourth one, choose the correct statement from the following. Steel is having more elastic than rubber. So this statement is wrong. Fluids have Young's modulus. No. By applying the force stress on the fluid, there will be not only change in length, there will be change in area. Shear will get occur. Shear means shape of the body is changing. So this is not the correct answer. Solids have Young's modulus. Yes. Bulk modulus, volume also can be changed, and by applying tangential force, shear also will come into picture. So this is the answer. C is the answer for fourth question. Next, two wires A and B are of same length. Length is same. So write down here, length is same. The diameters are in the ratio of D1 by D2 is equal to 1 by 2. And the Young's modulus are in the ratio of y1 by y2 is equal to 2 by 1. And if they are pulled by the same force is also same. So length is same, force is same. Then their elongations will be in the ratio of. See here, we know Young's modulus formula is nothing but formula for Young's modulus equal to F into L by A delta L. Okay, so here he said that force is same, length is same. So force and lengths are same. So F1 equal to F2, L1 equal to L2. Or shall I will write the full solution for this one. Young's modulus of wire A is equal to force on wire A by length of wire A divided by area of wire A delta L of wire A. Next, similarly I am writing YB equal to force on B wire, length of the wire B divided by area of wire B into change in length of wire B, like this. I have written the formula for Young's modulus of A and Young's modulus of B. Divide Young's modulus of A with B. He has said that length is same, force is same. Length same means LA is equal to LB. And force is also same. He said FA is equal to FB. Okay. So now I am writing it as, so LA equal to LB. These two get cancelled. And forces also get cancelled like this. So here I will get it as YA divided by YB is equal to what is left over here? 1 by A of A into delta L of A. When this come to numerator, the reciprocal value of this one is nothing but AB into delta LB. Okay, reciprocal of this one is nothing but it will come like this. So Young's modulus of A by Young's modulus of B is equal to AB divided by AA. AB is nothing but pi dB square by 4 divided by pi dB dA square by 4 into change in length of B divided by change in length of A. Change in length of B divided by change in length of A. Okay. So now pi by 4 get cancels. So here YA by YB has given it as YA by YB, Y1 by Y2 equal to 2 by 1. So 2 by 1 is equal to dB square by dA square. dA by dB is nothing but 1 by 2. dB by dA or d2 by d1 is equal to 2 by 1. So dB square by dA square is nothing but 2 by 1 whole square. That is nothing but 4 by 1 into delta LB by delta LA. Cross multiply. On cross multiplying, you will get delta LA by delta LB is equal to 4 by 1 into 1 by 2. So you will get the answer as 2:1. 2:1 is the answer. This is the answer. Okay. Hooke's law essentially defines stress, strain, yield point, elastic limit. Within the elastic limit, we know that stress is directly proportional to strain. This is nothing but Hooke's law. Longitudinal strain is possible in the case of only solids. Length, longitudinal means length. Length, change in length by original length. Length changes only in case of solids, not in case of gases, not in case of liquids. Okay. Next, an iron bar of length L meters and cross-sectional area A meter square is pulled by a force of F newtons from both ends so as to produce an elongation in meters. Which of the following statements is correct? So he has given that length is changing, so we use, in the case of change in length, we use Young's modulus. Young's modulus Y equal to F into L by A delta L. Here in this case, in every option elongation is there. Elongation is nothing but delta L. So delta L is equal to F into L by delta L equal to F into L by A into Y. Okay. Elongation is directly proportional to force. Elongation is directly proportional to length. Elongation is inversely proportional to area. Elongation is inversely proportional to Young's modulus. So elongation is inversely proportional to length. No, wrong. Elongation is directly proportional to area. Wrong, because it is inversely proportional. Elongation is inversely proportional to area. This answer is correct. Okay. A body of mass 1 kg is attached to one end of the wire, and that body is rotated in a horizontal circle of diameter 20 centimeters, 40 centimeters. So radius will be 20 centimeters. Okay. And mass is 1 kg and speed v equal to 2 meter per second. what is the area of cross section of the wire? What is the area if the stress developed in the wire, stress is given, stress is equal to how much? 5 into 10 to the power of 6 Newton per meter square. So here we know stress equal to force per unit area. Force per unit area. Stress is equal to force per unit area. So we know stress, we don't know force. Here we need to find out what is area. So in order to find out the force here, what I am doing, see a body of mass 1 kg is attached to one end of the wire, and this wire is rotated in a horizontal circular motion. When it is moving in a horizontal circular motion, what force causes it to rotate in circular motion? Centripetal force. That force is equal to mv square by r. Okay, find out the force value by using mv square by r. M is given as 1 kg, v is given as 2 meter per second, r is given as 20 centimeters, that is equal to 0.2 meters. So find the force first. If you know the force and stress, you can find out area. It will be turned out as 4 millimeter square. Okay, two wires have the same material and length. Here he is talking about length, so we should take Young's modulus. Two wires have the same material, so Young's modulus is same and length is same, but their areas are in the ratio of A1 by A2 is equal to 4:3. If they are stretched by the same force, he has given force is also same, their elongations will be in the ratio of how much? So we know y is equal to F into L by A delta L. And rule out the quantities which are same in the two wires. Young's modulus is same, length is same, force is same, because they cancel together when we take the ratio. Okay, so A1 equal to A delta L, or delta L is equal to 1 by A. Delta L, bring this to this side. So delta L equal to 1 by A, reciprocal of A in this case. So here delta L is inversely proportional to A. That means delta L1 by L2, delta L2 equal to A2 by A1. What is A2 by A1? 3 by 4. 3 by 4 is the answer. This is the answer. Okay, which of the following types of stress causes no change in shape? No change in shape. So see here, compressive stress. In the case of compressive stress, that is, if we apply the force in two sides, the shape will be changed. Isn't it right? And also in case of shearing stress, but in this case, we need to apply the tangential force. Because of tangential force, the object will be shaped like this. So shape is changing. So this is also not correct. So hydraulic stress is the answer. There is no change in shape. Here in hydraulic stress, when we apply the force in all directions, there is no change in shape, but there is a change in volume. Change in volume. Okay. So answer is B. If the load is increased beyond the dash point, the strain increases rapidly for even a small change in the stress. We have discussed in stress strain curve. After yield point, strain is more even for less application of a stress. Next, 13th question. Two wires A and B made up of the same material and have their lengths in the ratio of 1:2. Again, he is talking about length, so we need to take the Young's modulus formula. Young's modulus is same for both. In Young's modulus is same because they are made up of same material, and lengths are in the ratio of L1 by L2 is equal to 1:2, and diameters are in the ratio D1 by D2 is equal to 2:1. And if they stressed with the same force, force is also same. Force is same. The ratio of the increase in length of A to that of length of B. Ratio of increase in length. Increase in length is nothing but delta L. We know that y is equal to f into L by A delta L. Okay, so here he is talking about change in length. So delta L, write the formula for delta L. Delta L equal to f into L by A into y. F into L by A into y. So here he has mentioned that Young's modulus is same. So same Young's modulus will cancel out. Force is also same, will cancel out. So delta L is directly proportional to length, and delta L is inversely proportional to area. Therefore, delta L1 by delta L2 is equal to directly proportional to length, that means L1 by L2, inversely proportional to area, so it means into A2 by A1, inversely proportional, so I am writing A2 by A1. Okay, he has given L1 by L2 value, and also A2 by A1 is nothing but D2 square by D1 square. D2 square by D1 square. Area is nothing but pi d square by 4 in terms of diameter. So d2 square by d1 square. d2 square by d1 square is nothing but 1 by 4. 1 by 2 into 1 by 4. You will get answer as 1 by 8 is the answer. So this is the answer. Okay. When the pressure on a metal cube is increased by the pressure, increase in pressure, that is change in pressure equal to 10 to the power of 7 pascals, and the volume decreases by how much? Change in volume per unit volume. Fractional change in volume is 0.015%. That means 0.015 divided by 100. Now he is asking about bulk modulus. You know formula for bulk modulus equal to delta P by delta V by V. So by substituting this, you will get the answer as 6.67 into 10 to the power of 10 pascals. Okay, which of the following statement is correct? Strain is always proportional to stress. Strain is proportional to stress within the elastic limit. Answer B is correct. This is repeated question. Sorry for it. 16th question. What is the pressure required to reduce the given volume of water by 2%? Volume is decreases by 2%. That is fractional change in volume is 2%. That means 2 divided by 100. Okay, and he has given bulk modulus as 2.2 into 10 to the power of 9 pascals. I hope this is also repeated question. So he asked to find out what is change in pressure. So we know bulk modulus equal to change in pressure divided by fractional change in volume. So change in pressure equal to bulk modulus into change in volume by unit volume. So bulk modulus is equal to 2.2 into 10 to the power of 9 into change in volume is nothing but 2 by 100. So 2 into 2, 4.4 into 10 to the power of 7 is the answer. This is the answer. The units of stress and strain respectively. Stress is nothing but force per unit area. Restoring force per unit area. Restoring force is nothing but internal force, not applied force. Okay, that means Newton per meter square or pascals are the units of stress. And strain is nothing but it is the ratio of two same physical quantities. So no units are there. So answer is Newton per meter square, no units. Or other answers maybe pascals, no units are the answer. Newton per meter square is equivalent to pascals. We have discussed already. Right. Next, 18th question. The actual length of a wire is 1 meter, diameter is 2 meter. If a 10 kg object is hung with the wire is extended by 0.5, what is the Young's modulus? He has given actual length L equal to 1 meter and diameter equal to 2 millimeters. That is radius equal to 1 millimeter. 1 millimeter. So find out the area by using the formula pi r square, and that wire is being hung by 10 kg mass. So force equal to, what is the force acting on the wire? M into G. So mg. So here m is 10, G is 9.81. So you will get the answer for force here. And now he has given delta L value also. Delta L is equal to 0.5 mm converted into meters. Now use the formula y is equal to f into L by A delta L in order to find out the Young's modulus. So you will get the answer as 6.24 into 10 to the power of 10 pascals by substituting all the values given. Right. Choose the correct statement from the following. I hope this is also repeated question. Solids have Young's modulus, bulk modulus as well as shear modulus. This is the answer. Right. What is the SI unit of compressibility? For bulk modulus, Young's modulus, shear modulus, for all the modulus, elastic moduli, for elastic moduli, that is for bulk modulus, here in the case bulk modulus, the units are Newton per meter square or pascals. Okay. Compressibility is the reciprocal of bulk modulus, that is 1 by B. So units of B are Newton per meter square. Units of compressibility are meter square per Newton. Meter square per Newtons are the units. Okay. Now 4 wires whose lengths and diameter respectively are given below. First one is nothing but length, second one is diameter. Are made up of same material. Material is same. So Young's modulus is same because he is talking about length. Which of these will have the largest extension? Delta L. When same tension is applied, when same force is applied. If force is also same, materials also same, which one is having large extension? By using the formula y equal to F into L by A delta L. So he is talking about delta L. So obtain expression for delta L. Delta L equal to F into L by A into Y. Okay. So here he has mentioned that force is same, Young's modulus is same. So here cross out the force, Young's modulus. So you will get delta L is equal to L by A. Delta L equal to L by A. So delta L is directly proportional to length, inversely proportional to area. So here delta L, that is L by this one is nothing but area equal to pi d square by 4. That is change in length is directly proportional to L by d square. Okay, L by diameter square. Pi constant, 4 constant. So I am writing directly L by d square. So for first one, L is nothing but 0.5 divided by this one is nothing but 0.5 whole square diameter. Calculate this value. And delta L for second one is 1 by this length is 1 millimeter. You can cross it out because the length is in millimeters. So extension will be large for extension. Delta L will be large for large lengths. So millimeter is smaller than meters. So answer must be in terms of meters. So answer might be either A, C or D, not B, because B is in millimeters, its value is very less. We know delta L is proportional to L, so no need to check this B. So check C now. So delta L is 2 meters divided by 2 millimeter square, 2 square. 2 millimeter square. So sorry 0.5 millimeters, that is nothing but 0.5 by 0.0005 whole square. This is 0.002 whole square. And for D, this is for A and this is for B, not B, not this is for C and this is for D. Calculate this value for D also. So you will get the answers and so you can compare. Okay, this is for A, this is for C and D. For D, delta L is proportional to 4 meters and inversely proportional to 0.004 whole square. Calculate these values, you will get the answer. The answer is A because its reciprocal value is very less. Okay. Delta L is proportional to length and inversely proportional to area. That is nothing but inversely proportional to D square. So D square value is less in the case of A. So correct answer is A. You can find out by using calculator also. Substance which can be stretched to cause large strains are called elastomers. This is already given in the textbook. Define elasticity. Elasticity is nothing but property of the material which regain its original shape and size after removal of deforming forces. Define plasticity. After removal of deforming forces, it will not come back to its original shape and size. So such materials are called as plastic materials, and the behavior is called plasticity. And stress is nothing but stress is equal to restoring force per unit area is called stress. Restoring force is nothing but internal force, not external force. When we apply some amount of force on an object, that objects also exert equal and opposite force on us. So that force exerted by object on external thing is nothing but internal force or restoring force. So here stress is nothing but restoring force per unit area, not applied force per unit area. It is the restoring force per unit area. Strain is nothing but change in the dimension by original dimension. Define Hooke's law. Describe the behavior of wire under gradually increasing load. Stress strain curve. Discuss about stress strain curve. Define Young's modulus, bulk modulus, shear modulus. Okay. Now the final question is three wires A, B, C made up of same material and radius, made up of same material and same radius and having different lengths. Lengths means we need to take the Young's modulus. Y equal to F into L by A delta L. F into L by A delta L. So the graphs in the figure below shows the elongation versus load. The longest wire is. So here he mentioned that material is same, so Young's modulus is same, and also radius is same. That means area is also same. So the elongation versus load. So here we know that slope equal to change in y by change in x. Change in y is nothing but elongation delta L. On y-axis delta L is there, divided by x. X is nothing but load is there, force. Okay, here, from here, so I am rewriting it as delta L is equal to F into L by A into Y. Okay, and I need to take the delta L by F. I want to find out the slope for this curve, elongation versus load curve. Delta L by F is equal to L divided by A into Y. He has given that Young's modulus is same, area is also same. So delta L by F is nothing but slope of elongation versus load curve. Slope is directly proportional to length. So length is directly proportional to slope of elongation versus load curve. If slope is more, length is also more. If slope is less, length is less. So among A, B, C curves, which one is having largest slope? Curve C is having largest slope. So if slope is more, length is also more. So the longest wire is wire C. Slope of curve C is more. Therefore, length of C is more. So this is the answer. So with this, question bank of chapter number 10 comes to an end. Thank you, students. Bye-bye.